I am now going to introduce quickly David Silberstein. A little bit about David. He is the Director of Consulting Services, a Senior Data Architect at CGI, and a self-declared, and I'm not using this word, he's a self-declared Yinzer living in Franklin Park. When do you become a Yinzer? Are you born? 1998? Yep. That's how you become a Yinzer?
Well, I moved here.
You moved here?
In 1998, and then maybe 5 years.
Really? Okay, because I moved here in 2001, so I'm not a Yinzer. So he has 25 plus years experience across industries in data management, governance analytics, business intelligence, data warehousing, strategic consulting, end-to-end system delivery, and program management. His previous experience includes Clarity Insights, Leidos Health, Teradata, and Cerner and Accenture, so across a lot of different industries. With that, I'm going to have Dave come up here, and we're going to get started. So thank you, everyone, for being here. We have plenty of coffee. We have breakfast, but enjoy yourself today. Thanks.
All right. Good morning, everybody. See if I can get this thing to work. Yeah. Okay, so the title says State of the Industry 2018, but it's actually Dave's take on big data and what he thinks is important. Audrey mentioned one day we'll have an app that covers all the data, and we're sadly pretty far from that right now. So I'll talk about, the bio we did already, the definition of big data, just a couple of trivial use cases, and then the governance portion of it, which I think has to do with, it plays into all the siloed systems that Audrey was talking about. So what is big data? Just to level set, it's a term used to refer to the study and applications of data sets that are so big and complex that traditional tools are inadequate to deal with them. So, which means pretty much relational databases and those types of associated tools. And basically just has a much higher volume, velocity, and variety than conventional types of data. Big data is growing very quickly. A lot of people have different ideas on how fast it's growing. Some are saying it's 20 billion this year, some are saying it's 60 billion, but everybody's in agreement that it is growing at an exponential rate. Some of those variances have to do with the way that people count big data, what they think is big data, and or whether it's just data storage in general. But everybody knows that it's growing. Likewise, the revenue is increasing, the revenue, the size of the industry. There's variation there. Some people say it's 150 million, some people say a billion, some people say it's 50 billion, but it's lots of billions. So I think we can all agree that it's a big industry. Just a couple of use cases. I'm sure most people are familiar with these. One is the 360 view of the customer, where you've got somebody who calls in and you're getting all this data from the CRM system and recent calls and email messages and chat sessions, and you can use that to cross-sell and upsell, and also to try and predictively figure out what sorts of problems they might be having and how you might be able to solve them. That could even extend to tracking devices. If a lot of the auto insurance companies now are installing tracking devices in the cars, and that helps them to figure out, if you're looking like you're going to get a lot of speeding tickets, or if they see a lot of fast stops, maybe they think you might be a candidate for a driver training course or something like that. And all those things are used to prepare staff to, as I said, cross-sell and upsell and sort of predictively figure things out. And that is a classic example, because it's something that you really can't do with a lot of the existing tools that are out there. You couldn't do that with a typical relational database like Oracle or Teradata or something like that, just because there's too much data. It requires too much massaging to get it into a format where you could do those type of analytics. But with big data and its ability to deal with less structured, semi-structured, unstructured types of data. You can't do that. Another use case is the preventative maintenance, similar type of thing, trying to figure out in manufacturing and agriculture, transportation, when things are going to break down, how they're going to break down, and how you can sort of address that before it breaks down. And we've had extension into healthcare, which has much uglier and diverse types of data in terms of population health, trying to reduce hospital admissions, and keeping people out of the hospital, keeping them taking their medicine, and those type of things. And that's more dependent on IoT, the Internet of Things, so sensor data, your Fitbits, and can be like for people with diabetes, can be glucometers, of course, for manufacturing jet parts or whatever. You can have accelerometers and temperature sensor and those type of things. And once again, another use case where the classical technologies won't work. Okay, so now on to the meat. Why do we need a different approach for big data governance? How can we address the challenges, and what are the capabilities, tools, and technologies available? So to kind of preface this, if you think about the sort of the flow of data within a system, I think of it as the data comes from the sources. It goes into a repository, which doesn't correspond to this necessarily, but it comes from the sources, it goes into a repository, and then it's consumed. There's different layers. And typically, the data governance that we've had in the era of structured data has to do with what's going into the repository. And it's all very strictly governed. You have very strict definitions around what the concepts are, what the definitions are, what's a customer, what's a patient, et cetera, et cetera. And in big data, you can't really do that because you don't have the luxury. You've got so much data that's moving so quickly that you don't have the luxury of being able to go through that rigorous structured approach that you would go through in sort of old school data, which is the whole modeling exercise and that sort of thing. So I sort of look at it, I'm trying to think, what kind of analogies can I bring to bear on this? So, I think about it in that old school data for a business concept or a data element. It's more along the lines that you have a very detailed set of information, almost like a library for each data element. You've got kind of a book behind it. And in the world of big data, you've really got what's more of a metadata directory. And you have to do some governance around what you allow to come into your repository or your data lake, or else if you don't, then it turns into a data swamp. But the type of analysis that you do is much less analytical, much less deep. So you've got a directory, you've got an idea of what's in your repository, how it comes in, and how it corresponds to the definitions that you're trying to track, the data definitions, but the real analysis comes in when you actually look at the data. So what's the technology that's used to do this? Is Hadoop presently is the main one that's in use. There are other ones as well, and there's a lot of tools that allow you to use conventional tools that you can do SQL on Hadoop. But that's the storage and processing layer for the raw enterprise data. It's, of course, much easier to scale up. You can either do it on-prem or you can do it in the cloud with folks like Google or AWS or Azure. And it's got all different types of capabilities that you don't have in a model repository. It requires new people and process and technologies to think differently and work differently. Now, I mean, it's still, I would say, my take is that it's still 75% people and process and 25% in technology and tools. So we have all this great technology, and one of the things that I've seen over the years is that the rate at which the technology and the capabilities are progressing often outpaces the processes that sort of direct those. So there's a lot of neat stuff out there, but trying to figure out how to use it and how it conforms to the business can often be a challenge. So what that, what I was talking about earlier with the library versus the directory is goes into the metadata management. That is now a big part of big data, and it's different for semi-unstructured data. So you're asking different sorts of questions, not around what is the definition for a particular data term, but what data sets do I manage and what are their attributes, where are they located, who owns it, when was it generated, and how was it sourced and transformed. It's just rapidly growing. You need to have a very agile process for addressing these issues. And then on the infrastructure side, you've got the security and auditing piece of it across the different methods such as Hive and MapReduce and Spark. So there's access layer security, auditing and lineage, authentication, authorization, and then data masking and pruning, because sometimes you'll have privacy concerns. You'll have, particularly in healthcare or banking, you'll have personally identifiable information. You want to set up sandboxes where people can access that without having to go through a big privacy deal. So you can mask and you can prune that data so that the identified data is available as well. Any questions? Great. Okay, so what does that mean in terms of a governance model? We take these pieces and we build them out into the major subject areas of governance, which is auditing. So, who is accessing the data, and who's been doing an analysis, analytics on the data. Just because it's a sandbox doesn't mean you don't want to have people. You don't need to have that. Lineage is important, tracking how the data moves through the system, how the data is transformed, and which data elements are identical or overlap. The patterns for data ingestion and accessibility, are we bringing in data once a day, once a week? Are we refreshing it? Are we doing incremental changes? And those type of questions. The data quality, what does data quality mean in terms of your particular data set? The pattern for assessing that within big data, and then the security considerations within the big data environment. One concept that's somewhat important is also the idea of a gate in the SDLC process. So that makes sure that everybody kind of checks in with governance to make sure that if they're using a new data source or something like that, that it goes through governance, and you make sure that they're not coming up with a new definition that hasn't gone through it's okay to come up with that new definition, but it needs to go through the governance process. Everybody needs to be in agreement, and clearly there have to be different levels of that. So the idea for something that you're doing in a sandbox is not going to be the same as something that you're bringing into production. Okay, and lastly, here's just an overview of the tools that are available to do these different functions. So for metadata management, you can use Atlas or Calibra, Informatica, Talent, and Tahoe, MDM, a lot of the same ones. Data quality management, there are different tools from a lot of those vendors. And then security, compliance, and audit, Kerberos, Ranger, Falcon, data governance, Trillium Director. All right. So that is my take on big data governance. It's a broad framework, and certainly willing to talk and discuss it with people. Lots of times I find data governance kind of gets pushed to the back in many of these efforts because it's not as much technology focused, and you can't answer the questions as easily. It requires a lot of different parties to come to the table, and it's a somewhat complex and not always pretty process, and it means different things works out differently in different places.